Hi friends, myself Aditya Reddy. I am from SV Engineering College. Today I would like to explain my project Home Automation. The main contents of the project are abstract introduction, features, requirement, IOT, embedded system, microcontroller and microprocessor, Arduino IDE, PICSIMLAB, Blynk IoT app, Blynk app cloud platform, design components, application, conclusion, output, and project demonstration. Abstract. The main objective of this project to develop a home automation system using an Arduino IDE with using PICSIMLAB and Blynk IoT app. As technology is advancing, so houses are also getting smarter. In order to achieve this, PICSIMLAB is interfaced to Arduino IDE with the using of serial port emulator. A Blynk IoT application on the cell phone sends on or off commands to the where loads are connected. By touching the specified location on the Blynk IoT, the load can be turned on or off remotely through this technology. Now, introduction. Home automation is refers to the automatic and electronic control of household features, activity, and appliances. In simple terms, it means you can easily control the utilities and features of your home via the internet to make life more convenient and secure, and even spend less on household bills. Read on to find answers to some of the most common questions about home automation technology and get a few ideas for home automation solutions to incorporate in your home. Home automation is a network of hardware, communication, and electronic interfaces that work to integrate everyday devices with one another via the internet. Each device has sensors and is connected through Wi-Fi, so you can manage them from your smartphone or tablet whether you are at home or miles away. The picture shows how the Blynk app and the house components are connected. Now the features of this project. Being able to control devices remotely means things link unlock the door for a planned city without having to leave a key under the mat. You know, when you all comfort in bed but realize you have left the bathroom light on. With smart light bulbs, you can turn them off from the comfort of your bed without having to leave those light bulbs. You can turn them off from your comfort of your bed without having to leave those high thread count sheets. How many times you have left the heat unblasted while you have out of the house for 8 hours. With home automation, you can set the things like thermostats and schedules to make sure you are not wasting energy. A study found the Nest thermostats in particular can save about 12% on heating and cooling costs. Requirements of this project are knowledge about embedded C and C++ program, LED, temperature system, LDR, serial tank, in serial communication, Ethernet shield, Blynk IoT app. Now, Internet of Things. The Internet of Things describes physical objects with sensor, processing ability, software, and other technologies that connect and exchange data with other devices and systems over the Internet or other communications networks. Internet of Things has been considered a misnomer because devices do not need to connect it to the public internet. They only need to be connected to a network and be individual addressable. The field has evolved due to the convergence of multiple technologies, including computing, community sensors, increasingly powerful embedded systems, and machine learning. Traditionally, fields of embedded systems, wireless sensor networks, control systems, automation, independently and collectively enable the Internet of Things. Now, embedded system. Any combination of hardware and software which is intended to do a specific task can be called as an embedded system. An embedded system is a combination of computer hardware and software designed for a specific function. Embedded system may also function within a large system. Now, microcontroller. A microcontroller is an integrated circuit device used for controlling other portions of an electronic system, usually via a microprocessor unit, memory, and some peripherals. These devices are optimized for embedded applications that require both processing functionality and agility. Responsive integration with digital, analog, or electromechanical components. Microcontroller is a well chosen name because it emphasizes defining characteristics of this product category. Now, microprocessor. Microprocessor is a controlling unit of a microcomputer fabricated on a small chip capable of performing ALU. Means arithmetic logical unit operations, and communicating with the other devices connected to it. Microprocessor consists of an ALU register array and a control unit. ALU performs arithmetical and logical operations on the data received from the memory or an input device. This is the flowchart of how the microprocessor works. Arduino IDE. The Arduino Integrated Development Environment or Arduino software contains a text editor for writing code, a message area, a text console, a toolbar with buttons for common functions, and a series of menus. It connects to the Arduino hardware to upload programs and communicate with them. The Arduino platform has become quite popular with people just starting out with electronics, and for good reason. Unlike most previous programmable circuit boards, the Arduino does not need a separate piece of hardware. In order to load new code onto the board, you can simply use a USB cable. Additionally, the Arduino IDE uses a simplified version of C++, making it easier to learn to program. Finally, Arduino provides a standard form factor that breaks out the functions of the microcontroller into a more accessible package. This is the interface of Arduino IDE. Now we will go to PICSIMLAB. PICSIMLAB is a real-time emulator of development boards with integrated MPLABX debugger. PICSIMLAB supports some microcontrollers from PICSIM, some from SimAware and some from UCSim. PICSIMLAB have integration with MPLABX Arduino IDE for programming the board microcontrollers. As the support of PICSIMLAB is to emulate real hardware, it does not have any source code editing support. For code editing and debugging, the same tools used for a real board should be used with PICSIMLAB, such as MPLABX or Arduino IDE. Now, Blynk IoT app. Blynk was designed for the Internet of Things. It can control hardware remotely. It can display sensor data. It can store data, visualize it, or do many cool things. It is an IoT platform of iOS or Android smartphones that is used to control Arduino, Raspberry Pi, and Node MCU via the Internet. This application is used to create a graphical interface or human machine interface by compiling and providing the appropriate address on the available widgets. The main focus of the Blynk platform is to make it super easy to develop the mobile phone application. As we will see in this course, developing a mobile app that can talk to your Arduino is as easy as dragging a widget or configuring a pin. With Blynk, you can control an LED or a motor from your mobile phone with literally zero programming. This is actually the first experiment that I will demonstrate in this course. You can use it to monitor the soil humidity of your vegetable garden and turn on the water or open up your garage door with your phone. This is the interface of Blynk app cloud platform. The block diagrams of this project. This is the temperature control system and this is the water tank inlet and outlet value control. Now the design components. This is the ETH-W500. Next, temperature system. And next, light dependent resistor and LEDs. Next, the LCD. This is the LCD HD 4478 and serial remote tank. It shows the water level of the tank. Next, let's move on to the project demo. Now we are in Arduino software. This is the C program of this project. I have already implemented C program in it. I have already created C program for LDR. I have already created C program for LDR sensor and header file for it and main.h and the main.h. The pins are used in this for a serial tank C program, serial tank program, temperature system C program and temperature system. We use AUG02 program username here. We need to copy the Blynk ID from the Blynk app. Here we use the device name from the Blynk app and the authentication token also. Then that's it. We need to run the program now. Compilation is done. Compilation is done successfully. Now we are in PICSIMLAB. This is the board we are used in this project. This is the Arduino IoT board. We use the microcontroller ATmEGA328P. These are the spare parts we are used in this project. This is the LED. This is the temperature system. And this is the LDR sensor. And this is the serial remote tank. Check whether the all ports are correct or not. Correct. All set. This is the Blynk app. We keep our Blynk app aside to control it. Now we load our X file. The inlet value and water increases. Here the inlet value water increases. This is the maximum level. If we outlet it, the outflow will go. Whether we can stop this outlet. Now we see the heater. We turn on the heater. The temperature increases. Using the roller, we can decrease the temperature also. Here we see the LEDs. When the temperature reaches high, the LED will glow. Now the outlet is off. That's it, the project. This is the output of the project. Next, the application. Applications of this project are: through this home automation project, we increase or decrease the room temperature according to user comfort. Then, with the help of Arduino application, when water tanks fully fill, it notify user. By using LDR sensor in this project, we can control our garden light also. The conclusion: the home automation should be simulated on the PICSIMLAB simulator. Blynk IoT mobile application used to control the device should be able to control the lights, temperature of the home, inflow and outflow of water in the water tank. Using Blynk IoT application and PICSIMLAB simulator, simulated home automation where LED temperature system, serial tank resemble light, heater, cooler and water tank in real time. CLCD acts like as a CLCD acts like a dashboard used for displaying the events widgets from Blynk IoT app. Like button widgets are used to control heater, cooler and inlet valve and outlet valve. Gauge widgets to display the temperature and volume of the water. Thank you.